Let's look at algebra of residue classes, and let's begin with addition. Okay, and let me just write this down because we are going to refer to this. So 3 mod 3 is equal to 0. 4 mod 3 is equal to 1. 5 mod 3 is equal to 2. 6 mod 3 is equal to 0. In the last session also we did this, but I need to refer to this. So let me 1. 8 mod 3 is equal to 2. 9 mod 3 is equal to 0. 10 mod 3 is equal to 1. Okay, now let's see. If you notice, if I add these two, what do I get? 3 plus 4 is equal to 7. And correspondingly, what I do is I add these two. 0 plus 1, it gives me 1. So let's go to 7 and 1. So 7 is 1 and its residue is 1. 7 mod 3 is also 1. Similarly, let's take 4 plus 5, which gives me 9. Now the remainder of 4 mod 3, 4 mod 3 is 1 and 5 mod 3 is 2. So 1 plus 2 is 3. But then what would be I can't write 3, right? So I have to write it as 0. 3 mod 3 will be 0. Okay. Similarly, 3 plus 6 is equal to 9. 3 mod 3 is 0 plus 6 mod 3 is 0. So this will also be 0. Okay. So 3 plus 6. 3 plus 6 is 9 and 9's mod 3 is also 0. Let's do 2 more. 5 plus 3 equal to 8. So 5 plus 3 is 8. 0 plus 2 equal to 2. So 5 plus 3, 8. Mod 3 is also 2. Okay. What about 4 plus 4 is 8. 4 mod 3 is 1 plus 1 is equal to 8 mod 3 is 2. So if class A and class B, residue classes A and B, belong to IM, then class A plus class B is equal to A plus B. Yes. An element of class A plus element of class B will give you the mod of the sum. By the way, modular arithmetic is straightforward, but it can be confusing. So if we are talking of 0, 1, 2, 3, now to do the modular arithmetic, this one, as I said, it can be a little bit tricky. So just to practice, we can use this type of a table. Okay, so 1, 2, and 3. 1, 2, 3. This is for addition. And here we write 0, 1, 2. 0, 1, 2. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2. Similarly, 1 plus 0 is 1. 1 plus 1 is 2. And 1 plus 2 is 3. But remember, we have to take mod. So 3 mod 3 is 0. Similarly, 2 plus 0 is 2. 2 plus 1 is 3. Mod 3 is 0. 2 plus 2 is 4. 4 mod 3 is 1. This is for mod 3. Okay. So if you practice enough, then you will be able to do it in your mind itself. Now, in case of residue classes, it can be written in different ways. For example, we can write it as A, or we can write it as A plus M, or we can write it as A plus 2M. So since this can be written in many different forms, we need to ensure that, or we need to show that addition of residue classes is well defined. Now to show that, we have to show that class A is equal to class C if and class B is equal to class D, then class A plus class B is equal to class C plus class D. So let's show that. Let's prove that. Now, class A is equal to class C implies that A minus C, where A is a member of class A and C is a member of class C, is divisible by, and similarly class B is equal to class D implies that B minus D is divisible by M. Again, where B and D are members of class B and class K. So now class A or class A is equal to class C implies, since it is A minus C is divisible by M, means M divides A minus C. Similarly, B is equal to D implies M divides B minus D. We can combine that. Since M divides both A minus C and B minus D, we can say M divides A minus C plus B minus D, which implies M divides A plus B minus C plus D. Actually, I should put a bracket here. Okay. Now, what does this mean? It means A plus B is congruent to C plus D mod M, which implies that A plus B class is equal to C plus D class, which implies plus B is equal to C plus S. So therefore we can say that addition of residue classes is well defined. Okay, so this was addition. In the next session we will look at multiplication. That's it for now. Bye.